In this video, I'm going to show you how I built this cargo bike. But first, I want to briefly tell the story of how I got to the point of building my own cargo bike. I grew up in the country, wide open spaces, big skies. It really has a lot going for it, but it's terribly lonely and isolating for a young person who doesn't have a sense of community there. The nearest grocery store was 16 miles away, so naturally we took cars for granted. When I was 21, I got my first car, and I loved driving on those rural roads. But then about 3 years ago, I moved to a more urban area, which was a huge upgrade for my mental health. I found that I was able to cover most of my daily needs just on foot. And I also learned just how miserable urban traffic can be. I started taking public transit more often just to avoid the traffic, and I started biking to some destinations that were near my shop because my shop is near a bike path. At some point I realized that I could actually do everything I need without a car, and I could get rid of a huge expense and liability in my life. I calculated how much I was spending to own my car, and I was kind of shocked to find that it was well over $10,000 per year. Turns out that's just the normal amount that Americans spend to own a car. So about 8 months ago, I sold my car, which also enabled me to move to a more attractive part of my city, which I had wanted to live in all along, but I couldn't afford it as long as I was paying for my car and a parking spot for it. That also put me in a place with much better biking infrastructure. I was never that interested in biking. I just figured I would either walk or take transit once I sold my car. But since both my shop and my home were in places with respectable biking infrastructure, I started to use it a little bit. And over time, I've realized that it's actually a surprisingly easy and fast way to get around. At first, this was all just kind of an experiment. I figured I could just buy another car if I really needed to. But we're now 8 months in, and I really don't miss it. I've been able to get the materials for all of my projects just with a regular bike or taking them on transit, except for the plywood for my modular cabinets, which I had a friend help me with. But I keep thinking that it would be so much easier to get large materials if I had a bike specifically built for that, and still without the stress and expense of driving. So that's why I built this. Although I have to admit, I haven't needed this bike in the past 8 months. So at this point, I built it more for fun than out of necessity. So now I'll show you some of its features, and then I'll show you how I built it. So the first most important things to know, this box is just temporary. I just happen to have this plastic tub that happened to fit perfectly, so I couldn't help myself, I had to put it on. Second thing to know is I am considering this entire bike to just be a prototype. I am planning to build a better one in the future, so there are some decisions that I made on this bike to make it sort of modular so that I can try different things, and I also made it pretty quickly and haphazardly, so it's not quite up to my normal standard of quality, I guess. The first thing that I did to make it modular, well, actually kind of the main only thing, there are bolt holes in here. And since it's all black, they're really hard to see. But all the way down the entire frame, we have these bolt holes. The kickstand is bolted onto them. They're in all sides of the frame tube. So this box, as you can see, is just bolted straight down to the top of that frame. This will enable me to try all sorts of different boxes. I can take this box off and put a flatbed instead, or I could possibly even bolt down some of my modular cabinets, have just like a mobile chest of drawers. I wasn't sure exactly what kind of box I wanted on here, so trying to make it perfect the first time was probably going to be a fool's errand, and if you can't make it perfect, at least make it adjustable. Well, in this case, make it modular. The back third of the bike, from the bottom bracket and the seat tube backward, is all just an old mountain bike. So I just cut off the old mountain bike right there. So the drivetrain, the bottom bracket, the seat post, everything is all just a donor bike. All of the parts that I used on this bike, I bought used from sort of a bike salvage place. I have an adjustable stem. That's also partly because this is a prototype. I want to be able to adjust that and try some different sort of seating postures, see what I like the best. The steering shaft goes down through this post. This post also has bolt holes in it all the way. It runs this little linkage arm down here, which pushes and pulls on this link that goes up to the side of the front fork. And then I have this nice sturdy kickstand down here. The kickstand is also bolted into the bolt holes in the frame, so I can experiment with the position of the kickstand, and I can also easily try different kickstands over time. So you might notice that this top tube looks a little weird. This is the original mountain bike's top tube, but it used to angle like this. and I cut it off and re-welded it down here. I'm not sure if this was actually a good idea because the frame is a little bit twisty side to side now, and having it up here may have helped with that, but I'm not sure. The big advantage of having it like this is that it has a really easy step over. It becomes kind of a mid-step frame. This is very helpful if I have stuff on the back rack, because I don't want to have to try to lift my leg over all of that. So this is an easier way to get on. This bike is relatively small, at least in the world of front load cargo bikes. The actual cargo bay from the inside of this tube to the inside of the steering post is 25.5 inches. The other thing you might notice about this bike is it is heavily inspired by Phil Vandelay's design. I'm gonna leave a link to his video about building a cargo bike in the description. He also sells plans for the cargo bike, which I bought, and they are fantastic. I did modify the design a lot to suit my needs. So I'm using a completely different size of tube here. This is a rectangular tube, so it's taller and narrower. Not sure that was a good idea because, again, the frame is a little twisty side to side, but it does seem strong enough up and down. But I think making it wider would have made it less twisty. And of course, I added all of the bolt holes. I also put this a bit lower than on Phil's design, so I had to add this piece to come up to the bottom bracket. Major shout out to Phil Vandelay. I definitely used his plans and his knowledge to help me design this. The total weight of the bike is 44 pounds without this plastic tub. Not too bad for a bike of this size. Although again, it is a little weak and realistically probably only has a cargo capacity of about 130 pounds or 60 kilos in the box. Plus I could put some more back here. My total cost in building this bike is a little under $400, so about equivalent to the cost of owning a car for 2 weeks. Of course, there are many more small nuances to the design, but I'll talk about those throughout the build process. So let's get started on the build. I started the project by making the main bottom tube that will go under the cargo box. And this has a ton of little nuts welded into it to make threaded holes. This way I can bolt anything I want onto this bike instead of being limited to just one cargo box. I'm alternating the positions of the welds to try to reduce warping. So starting with this one and then 2 on the other side, 3 here and 4 on the other side. I got them all welded in and now I need to grind them all flush. You'll notice that these 2 and the 2 on the other side here are a little different. The nut is actually machined so that it protrudes through the hole. Instead of on these, the nut is sitting fully below the hole. And that's because right here is where the steering is gonna go. So I needed a little bit more room on the inside, so I machined these nuts to open up the gap between them a little bit more. Here you can kind of see that from the inside. The 2 closest nuts look a little bit thinner because they're farther apart because they're inset into the wall. And here I'm drilling that hole for the steering shaft to go through. Here's one of those nuts machined down. This is going to be the vertical post that goes up to hold the handlebars, so it's also going to have the shaft running through it. So it gets those machined down nuts welded into 3 sides of it. Next I'm making 2 more frame parts that will hold the front wheel. And I forgot to film cutting this one, so I had to fake it. No one will ever know. And both of these frame tubes also get the nuts welded to the inside. By the way, I made a previous video about the process of how I'm welding these nuts onto the inside of the tube, so I'll link that below if you're interested. So here's how the frame goes together. The front wheel will be here. This is the cargo bay. The handlebars will be on the top of that. And I want to put a little gusset in this corner to reinforce that. And then also, I'm going to use this donor frame as the back portion. I'm only going to use from the seat post back, so I'll get rid of this triangle. But this bottom bracket is not going to be in line with this tube. So I need a short piece of tube to connect up to the bottom bracket. So the one end of this tube has a really steep angle on it to match up to the larger bottom frame tube, and then the other end I'm going to cut with a hole saw so that it's round to match up to the bottom bracket. So there I just drilled a small pilot hole through both walls, and that way I can drill at the same spot on both sides with this hole saw. And I just drilled through the outside walls with the hole saw and then cut the other walls with the bandsaw. I can already see it fits very nicely, so that's going to work. That just needs to go right here like so. And then we have our little gusset piece which goes right there in that corner. And that's the frame. I want to mount a water bottle holder right about here, so I'm going to just drill and tap 2 holes into the back of that. Yeah, this isn't going to work, is it? Based on how drilling through this seam was going, I'm pretty sure I would have broke my tap if I tried to tap through it. Anyways, I'm going to try putting these super tiny nuts in there by the same method that I used for all the others. I'm not sure if it's going to work on this small of nuts, but one way to find out. I'm not feeling very good about these because I barely got any weld on them, but hopefully it'll work because they only have pull force on them. Before I weld this all together, I want to drill a couple of holes in here, basically create an oval cutout. That's going to reduce a little bit of weight out of this basically unused wall in the tube, and also create a passage that I could maybe theoretically run a cable through in the future. I also need to cap the end of this, but before I do that, I want to weld in 2 more nuts that are basically going to be continuing this whole pattern. The nuts that get welded into this corner are kind of the reason this isn't a miter. I'm also more confident that I'll be able to get a good weld on this joint with it not being a miter, but it's mostly because of the nuts. Okay, I'm ready to weld this all up now, and I'm gonna start with this joint. I wanna make sure that this tube isn't rolled this way relative to this one. So to do that, I'm just gonna clamp it between 2 pieces of tube. And again, I felt more confident that I would get good welds on this corner if the one was overlapping the other like this instead of it being a miter. To mount this piece and keep the sides flush, I'll once again just clamp it between 2 pieces. I left a little gap here so that when I come back to weld that, I'll be able to sort of weld in that gap and hopefully get a better weld, deeper penetration. I'm not sure if that will really help, but I don't think it will hurt. And then I did the same thing for the short piece that connects to the bottom bracket, clamping it between 2 pieces with a slight gap. Looking at the inside of this joint, I feel fairly good about it. I don't think this is going to break. And then just grinding the outside flush so that I can bolt stuff flat against it. And now it's time to cut up the donor frame. This kind of made me cringe too, but I'll be reusing the top tube, so really only the bottom tube and head tube are going to waste. I didn't own one of these bottom bracket tools, but my local tool library had it, so I checked it out of the tool library. That's why I left this in until the last minute, so that I can remove the bottom bracket, weld it, and immediately put it back in. I don't have to check the tool out twice. I'm gonna use this bolt to keep it in place so that I don't damage the bottom bracket or the tool. Where the seat post meets the bottom bracket, there's a hole, and I'm not gonna have anything covering this anymore, so I'm gonna try to just fill that hole with weld and also finish welding the seat post onto the bottom bracket since it wasn't before. And now I can start assembling everything in my frame jig. This is a jig that I made earlier. It just holds the front and back axles in the correct place. I originally filmed making this jig, but I decided it wasn't worth including it in the video because it just wasn't that interesting. So I got that welded joint done, and now this is not strong enough. It needs some kind of triangulation for strength. So I could have left the original donor bike's top tube in here, and that would have angled up to approximately here. But I don't like the shape that that makes, because that forms a trapezoid, and a trapezoid is not very strong, because it's easy for it to bend like this. Whereas a triangle is really strong because it can't bend in any direction without one of the legs changing length. So I'm instead going to put it on an angle down about like this. This effectively creates a triangle because this link down here is so strong that I can effectively consider it to be a straight line. So I've made a straight line from here to here to here to here. Here's a little trick for how to notch the end of a round tube without any fancy tools. You can just use 3 straight cuts to effectively make a curve. So if you now look at that from the end, that's going to fit nicely against the other one. I don't have any formulas or anything for what these angles should be, but you'll get a feel for it with trial and error. There's a hole here, and I want to cover up that hole, so I'll put it about here. Making good progress. Now, I need to somehow mount the fork on the front, and for that I'm gonna turn something out of this piece of tube that will hold the headset bearings up here. I'm gonna need to turn this down because I need to make a press fit on the inside and also reduce the wall thickness because this is excessively heavy. So I've got both ends turned down to be a press fit with the headset bearings. This would be functional as is, but it's pretty heavy. I could turn down the outside to reduce some weight, but this is already 1.5 inch diameter, the same width as my frame. So rather than turning down the outside, I'm gonna turn the inside much bigger and only leave it thicker at the ends. All right, so it's kind of ugly on the inside, but I mean, aren't we all? So you can see here how this end and this end are both the proper diameter to press fit the bearings, but then in between them, it's bored larger to remove some weight. So you would never know it from the outside, but this is actually quite lightweight. I used the tailstock on my lathe to press the headset bearing races into place. Now I'll just need to notch this out so that this fits nicely. While I have this on here, I'm going to measure this so I know how much to cut off later. So if I put this ring on, thread this nut onto the top until it bottoms out, then the distance between these will be how much I need to cut off. I wrote that number down and we'll use it later in the video. Okay, I've got that filed so that it fits really nice, and now I'm going to tack this in place in just 4 places with the bearings in place, so this will be holding it where it needs to be, and then I'll take the bearings out so that I don't damage them when I finish welding this solid. And I somehow don't have footage of welding that solid, but here's proof that I did. Now I need to make a few parts to hold the brake and shift cables. So I made 3 of these little things, and these are for where the shifter and brake cables exit their housing. They go on just like this. So these will get welded to the frame. The bike already has a couple of them. This one is for the rear brake cable, and this one is for the rear derailleur. But I'm gonna weld on another one here on the bottom of the bottom bracket that will line up with this one, so the cable can span there. For the front derailleur, I'm gonna weld one of these on right in here, so that the cable will be able to span from there up to where it attaches right here. And then for the rear brake, I'll weld a second one on up here. There originally was one right here, but that's too close to the end, so I'll have to weld one on farther up. To hold this front one in place while I weld it on, I'm gonna stick it onto this piece of 1/4" rod, and I have the same one on this end, so that'll act as a parallel, and then clamp that to the tube. The 1/4" rod also gives me a longer reference to make sure that I have it mounted straight. I want to be sure that this one and this one are clocked to the same angle so that the cable will run parallel to this. So I'll just use this piece of angle iron, rotate it until it touches this one, and then rotate this around until it also just touches here. And now we have this cable that goes to the rear derailleur. So I just need this one to be in line with this one. I'm just gonna eyeball this, and I'll secure that with a sacrificial clothespin. Sacrificial because it will likely get destroyed by the welder. This washer is just to protect the threads from spatter. So this is the front derailleur, and the cable goes right through this groove. So for the cable holder for this one, I'm gonna just hold it down here and eyeball it, so it'll be straight in line with that groove. Okay, I'm done welding on the bottom bracket shell, so I can go ahead and put the bottom bracket in so that I can return the library's tool. I'm not sure how this is supposed to be done, but I imagine if I put this spacer in the one side first, but don't thread it all the way in, then it will act as a guide. There's a good chance I'll be taking this bottom bracket back out soon, because the reason I designed the frame the way I did is to leave room right here for a Bafang mid-drive motor. I'm not sure if I'm going to end up using that, but that's what I had in mind when I made this angle down. So I just turned all of these little guys. What those are for is to guide the cable once it's in the housing. Here's where the cable goes for the rear derailleur. I want to run it along the top side of this bottom frame member and then curve it up and run it up the back side of the steering post. The cable for the front derailleur can basically do the same thing. It will bend around to here, so it'll be secured here and then run up the back side here. The rear brake cable goes right here, and it will just bend and join the others going up the back of the steering post. Right here where the water bottle holder is, I'm gonna 3D print a little guide for all 4 cables, because the front brake cable will also be running through here. I don't have the full-length cable housings yet, but this gives you a basic idea, so I think it's nice and symmetrical. So next up I want to work on the steering shaft, which will be made from this piece of material. It's going to go down through this piece and then control a linkage up to the front. So for the top of this and the bottom of that, I'm going to use these headset bearings. And this part is a press fit diameter, so I'm going to need to custom turn a part to go in the top of this, as well as one to get welded on the bottom of the frame. I'm starting with solid square bar for the top bearing holder, because it's just the best material I had on hand. I'm not sure why I didn't start by cutting the corners off of this with the bandsaw. It would have really made things so much easier. Almost there. This long round section is just there to align it to the tube. So yeah, I did all of that work just to make something to stick into the end of the tube. Here I'm boring the inside diameter to the proper diameter to be a press fit with the bearing. And then here I'm just knocking the corner off at a 45-degree angle to make it look better. And then here I'm starting on the other part that goes on the bottom. I'm starting with a piece of flat bar for this. And boring that press fit. Cutting the ends out of this piece to reduce some weight. So if you look at this frame and imagine where the load is going to be, which is mostly here and here, it's kind of concentrated near the center and supported near the ends. So this corner right here is where there's sort of the most stress. And the problem is I put 2 bolt holes here, and then there's also the hole in the bottom. So this is kind of a weak point, and I can sort of imagine a crack propagating from here up through this one, and then over to here. I clamped this upside down in the vise so you can see it better, but basically this weak point is why I made this piece look the way it does. When it goes on here and I weld it on all the way along this side, that will sort of bridge over that weak spot and contribute quite a bit to the strength. So I was going to paint this yellow just so that if it got worn through or scratched back here on the back, it wouldn't show as much since it's yellow underneath. But the paint I'm using is garbage because this is an entire can of paint, like 5 coats, and it's clearly not covered at all yet. And I kept putting the coats on thicker because I wasn't getting good coverage, and I started to get some runs here. I guess I'm gonna sand the runs back off and just treat this as a primer coat and switch to my go-to paint, which is Duplicolor. Not sponsored or anything, but the problem with Duplicolor is they don't have any interesting colors. I'm gonna give up and just do black and maybe use some interesting colors for some accents. And here's what that looks like with 2 coats of paint, roughly half a can. It's already pretty much complete coverage. Next, I'm going to start making the steering linkage. So here I'm making the part that will attach to the bottom of the steering shaft. So this part is going to go right down here on the bottom of this so that when I turn the handlebars, it will push or pull on the steering linkage. But obviously right now it is super thick and super heavy, so I'm gonna reduce the thickness a little bit. And in doing that, I'll leave this end part full thickness so that I can turn a shoulder on that will fit the race of the bottom headset bearing. This part was thin enough that it kind of wanted to fit into the slot in this bandsaw, so I clamped a piece across that slot. That worked pretty well. This 7/8 inch tube will be my steering shaft, and I'm just rolling it back and forth on my table saw to make sure that it's straight. Here I'm just temporarily welding on a tube that will let me grip this with the lathe chuck. Here I'm measuring that distance that I figured out earlier and cutting off the threaded portion of the fork. I'm going to reuse this threaded part on the top of the steering shaft. Here's how the steering shaft goes on the bike. That lever sticking out the right side will push and pull on a linkage that pushes and pulls on the right side of the front fork. And now this part right here needs a shoulder on it for fitting the bottom headset bearing. I'll use my steady rest to help keep this end from flopping around and just keep it straight, using a dial indicator to get it running true. I have to be really careful not to run any of my tooling or my hands into this lever flying around. It's a bit dangerous, but that makes it fun. There are 4 holes in this so that I can adjust my steering ratio, but of course the ideal steering ratio ended up being halfway between 2 of them. Remember when I put these 2 little holes here and I welded the nuts on the inside? These are the really tiny nuts that I didn't really get welded in place very well. I thought they were going to be fine because the bolt is only ever pulling on them, so even though they're not welded in very good, they shouldn't break off. And I think they would have been fine, except that I tried to put the steering shaft in and I rammed the end of it into one of them and broke it off. The only sort of upside to this is my water bottle was going to be a bit too low anyway, because this top tube ended up being higher than I thought it would. So now I get the chance to mount this a little bit higher. So my solution is just going to be to weld on a couple of new nuts on the outside. And there's going to be a spacer behind this anyway, because I need that to hold the cables that are coming up here. I can just make that spacer have large holes to go around the new nuts that I weld on the outside. I'm just drilling through holes here to give some clearance for the end of the screw after it passes through the nut. If you're wondering why I'm using a quill stem rather than threadless, it's just because of the 1.1/8" diameter of the typical threadless kind that doesn't fit inside my frame. Okay, it's kind of coming together. So the steering now turns, and you can see how turning it moves that bar back and forth down there. So that will push and pull on a rod that goes up to the front fork. And I need to weld on a tab on the fork right here, and this tab will connect to the other end of that rod, so it'll push and pull on this side of the fork to steer the front wheel. I'm clamping the fork down to this plate to hold it level, and then this block of wood will keep it turned straight. So I have it clamped down on top of this piece, so that means the center line of this is 7/8 inch above the table. So I set up this tab with the hole also 7/8 inch above the table surface. So that way the axis of this will be in line with the axis of this. And now I can put those front headset bearings in place and mount the front fork. Here I'm machining away a little bit of the head of a bolt, and this is going to allow this heim joint to articulate a little bit more than it would have been able to without the machined head. I also machined a little bushing that will go on the other side of the heim joint to give it more articulation from that side. The heim joint gets attached to the front fork by this bolt, and then the bushing, and then it goes through that tab, and then I'll secure that with a lock nut. For now I'm using a regular nut, but this will be a lock nut later. So this is approximately how the steering connector rod is going to go. It needs this bend toward the front to clear the wheel when I steer left. You can imagine where the wheel is going to be in this position. So now we need to work on making the joint that goes on this end. This can't just be a ball joint, because if it was, the whole rod would be able to kind of flop this way. So this joint needs to be able to pivot around a vertical axis. It also needs a horizontal axis so that the rod can go up and down, and that's because the front head tube is on an angle. So when I steer to the right, it drops down, and when I steer to the left, it goes up. So the rod is going to have to move up and down as I steer. But we don't want it to have any axis this way. So it's just going to be a 2-axis joint like this instead of a ball joint. The steering rod attaches here and is able to move freely back and forth and pivot up and down. And now I need to make some bushings to fit inside of this to take up this slack, and also some washers to take up this vertical play. And I'll make that out of this Delrin. So I turned this little bushing, which is going to go on this bolt, and then I'm going to grind down the head of this bolt a little bit and weld it on. That will be the end of the linkage. These threads will give me some adjustment in the length of the linkage, and then I'll need to make another bushing to go inside of this one to go around that bolt. So I have both ends done. So here we have a ball joint that has all degrees of freedom and has a coupling nut on the end. And over here we have just the 2-axis joint with a coupling nut on the end. And these coupling nuts are to be welded into a pipe that will connect these two. Of course, that pipe is going to need to have a bend in it here, because when you turn to the left, the wheel comes out this side. I tried to model this in CAD, but I'm not very good at this sort of thing in CAD. And this is a bunch of weird compound angles. So I'm just going to wing it. But I did at least learn one thing from the CAD, which is that I don't want the pipe to come straight off of this one. I want it to come up to it at an angle. Otherwise, the arm will be too high out here. It needs to be angled down so that it's below the level of the box. The size of this tube is such that if I just put this in there just barely and tilt it to one side, I get about the angle I want. So I'll just hold that with my hands and weld it in place. I also want to angle this one at the back, like so. Gives me a bit more ground clearance and also provides more clearance for the kickstand. I had to grind a little bit of this nut to make it fit at the angle I wanted, but now I'm just welding it in the same way. And now threading that onto the end by the 2-axis joint. Just by trial and error, I think I have got this close enough that I can go ahead and mark where the tubes intersect and cut them to final length. With just a bit more trial and error, I seem to have something that works. So I'm able to get a pretty good angle out of the wheel here. I did cut this piece potentially a little too short. I was planning to put a corner piece in here anyway, but I think I'm gonna have to make the corner piece a little longer than expected. But yeah, I'm happy with this angle and everything, so I'm gonna take this off, try to leave it clamped on at this exact angle, and then weld it together. I decided to add a couple blocks to sort of act as fences for extra security to make sure I have that angle permanently locked, and then I can unbolt the ends of the rod so that I can take it off the bike. Since both of the ends are crooked and not in line with the tube, it's important that these aren't twisted. They need to be in the right orientation this way relative to each other. So I'm gonna go ahead and mark on this one where it's at. That way, when I take this one off to cut it, I'll be able to put it back on in the same clock position. I also marked where it met the end of this little fence block so that it would go back on with the joint the correct distance from the corner. So I marked where it needs to be cut. I'm gonna cut this at about a 19-degree angle because that'll be the appropriate amount for a miter. And I'm just holding my bandsaw as level as I can, and that'll get it close enough to the correct angle. I can always weld a little gap so it doesn't have to be perfect. And then repeating those exact same steps for the longer tube. And here I'm cutting off as little as I can so I don't shorten it too much. This front fork does have a disc brake mount, so I can upgrade to disc brakes later. Well, black is probably the worst color I could have chosen for trying to film it, because this stuff is not visible against the frame. But I've got the cable routed roughly how I want it to go up to the front wheel. I'm going to run it fully in housing just to make it easy, so I'll cut it about there. I 3D printed some little clips that I can use to hold the cables in place. So having these attached to the holes in the frame means that I can easily move this cable around as needed. So if I need to move it to accommodate a different style of box, that'll be easy to do. So I 3D printed this component. It's just got 2 slots running through it and 2 holes that line up with these. So we're going to run both these cables right along there. This goes over them to hold them in place, and then the water bottle holder holds that in place. So the front shifter is over here on this side, and the cables just lay better if they run down this side. So I'm doing that, but ultimately the front derailleur cable needs to go around this side. So that's why I'm crossing it over right here. So then I'll cross the cable for the rear derailleur back over the other way, and I'll run it under the other side of the bottle cage spacer thing. So now that can loop around this way. Looks nice and symmetrical. This is the cable for the front derailleur, which I need to install right now. And now feeding the last cable housing through that water bottle spacer thing, which is for the rear brake. And with all the shifters and brakes in place, the bike is now rideable. So I took it out for a test ride at like 10 p.m. around the parking lot. Before this bike can really be used as a cargo bike, it needs a kickstand and a cargo box. So here I'm getting started on the kickstand. So I have this piece that I cut the ends at 45 degrees, and then I bent these two pieces in the vise. So those will go on the ends. I'm going to weld one of them on right now, but leave the other one off for later. This tab has two holes in it that are the same spacing apart as the holes in the frame. So this is how this whole kickstand will mount to the frame. So the kickstand is going to pivot on this one and this one. But first I need to mount this on here. And it's going to be off center because of the linkage for the steering on the other side. Now I can bolt that other bent piece in place. I'll slip a piece of paper behind here to give it a tiny bit of clearance. And with that all held in the actual positions where it needs to be, I can tack it in place. I removed the bracket and welded everything solid, and then I welded in these two angle gussets to help make it a bit stronger. And now I need to weld in this bolt. And here it is all welded together and ready to attach. So I have these clamped down at the right distance apart, and now I need to custom cut this little tab to connect this bolt to this piece, and this is what it will pivot on. So I'm just going to kind of eyeball and draw a mark and then saw that off. And as far as the geometry of everything, like how high this hinge point is off the floor and how far apart these are and whatever, that's all just figured out by trial and error in CAD. Nothing fancy. Looks like I cut off a little more than I needed to, but it should be possible to weld that together still, so it's okay. And now I just need to make a second one of those, so I'll just transfer my line and cut this one as well, and that will go over here on the other end. Since the bracket is off center, I made these two slightly different thicknesses, so the one that's closer to the center and has more leverage on it is about 50% thicker than the one that's at the end. Now the parts are all welded up, so I can go ahead and mount the bracket back on the frame. And then mount the kickstand to the bracket. There's this nut in between the kickstand and the bracket, and when I tighten that nut, it holds the bracket tighter against the frame, but allows the kickstand to move freely on the bolt. Here you can see how the steering linkage can still move freely with the kickstand in place, but the kickstand still needs a spring because right now there's nothing to really hold it up. So I just put a bolt in the upper hole in the tube here, and that holds this spring. Now I'm experimenting to figure out where I want the other end of it, so I just have it strung through a washer. I can clamp that washer onto the bottom here. That seems to work. I just realized that the mass of this clamp is affecting my test, so I'm going to put a second clamp on it the opposite way to cancel that out. almost strong enough. I'm going to try a stronger spring. I think that's going to work. So there it is with the spring installed, and it doesn't work particularly great. I would like it if when I rock forward like that, it would pop up on its own, but I have to give it just a little kick and then it goes. But it does stay up on its own. So I'm gonna call it good enough. I'm gonna take it all back apart and paint it now, and then we're done. I have this really old, gross tote that's kind of broken on one side, so I'm gonna modify it a little bit and mount it on here as just a temporary box. The back wall of this box is angled outwards, and this is straight, so it doesn't really like to fit straight here. But this was already broken, so I'm just gonna cut it out around the steering post. I printed some solid plastic feet to protect the ends of the kickstand legs, because otherwise they're going to get all scratched up and rusty. I attached those each with a screw. So let's pretend that my friend's upstairs bathroom had a water leak and it damaged the ceiling of their kitchen below. So I'm gonna load up my cargo bike with a bunch of supplies and go fix their ceiling. This is gonna make a mess, so we'll need a shop vac and a shop vac hose and some drop cloth and a drill and a driver and drill bits and driver bits and some clamps, because you can never have enough of those. And some screws, and a utility knife, and a tape measure, and a circular saw, and hearing protection, and some 2x4s, which I'm also going to use to support the ladder. So yeah, here's the 6-foot ladder. And last but not least, we'll need the drywall. I don't have any drywall, so I'm just using plywood for this example. Having the weight off center with the ladder hanging off the side is not even noticeable. Like, it's totally fine. And of course, this is just an example. I didn't actually have a friend with ceiling problems, so let's go back to the shop and try something different. I want to try to put some weight really up high and see how it feels if it has a very high center of gravity. So I have a couple of my modular cabinets here that I'm currently building. I'm going to put those on top of the box, so they're stacked up here somewhere. Should be best to use these that aren't quite done yet, so if I crash and damage them, it's not as big of a deal. These cabinets typically weigh about 24.5 pounds, so this is 49 pounds with the center of gravity about at the handlebar height. That was too easy, so I'm going to add a drawer with 30 pounds of hardware in it to the very top slot. And that still felt too easy, still super maneuverable, so I added a 60-pound drawer of hardware just below the one that was already in there. So at this point I have about 50 pounds of cabinets and about 90 pounds of hardware at the very top of them. As you can see, it's still very maneuverable. It works just fine. The only problem is it's hard to start and stop, and at this point I could feel the frame flexing quite a bit, so really 140 pounds is pushing the limits of this frame. Speaking of weight limits, I took this load of 98 pounds of bricks and went to get lunch, and this was totally fine. So I guess having the center of gravity low, it's not too bad to carry 100 pounds. But I am definitely disappointed that my frame isn't strong enough to carry more, because the bike rides just fine with higher loads, but I can feel the frame flexing and I'm scared it will break. My main takeaway is this bike is so much easier than I thought it would be to ride, even with the weight really high, or with the weight off center, or with the weight really far out front. It doesn't matter, the bike rides just fine no matter what. The only problem is I made it too weak. So if I make a version 2, I need to just beef everything up by about 50%, because the bike handles just fine with almost 200 pounds in the box. There's no problem, except that I feel like I'm about to break it. So that's it for this one. I'm going to publish my SketchUp model for this on my website, so if you have any interest in taking a look at the design, you can look there. I often end videos by saying that I'm gonna make some modification to it in the future, then end up not doing that because I'm burnt out on the project by the time I publish the video. So I might make a new box for this in the future, because I want something wider and shallower and also a flatbed option, but no promises because I am burnt out on this project and I want to move on to something else. Anyway, that's it. Thank you for watching.